Hey everyone, welcome back for another deep dive. Today we're going to tackle a question that's been bugging philosophers and scientists for ages. Can quantum mechanics, that crazy world of subatomic particles, actually explain free will?
Yeah, that's a big one.
It is a big one, and we've got some fascinating excerpts from a book that explores the science of free will. We'll dig into all sorts of mind-bending concepts from quantum healing to the very structure of our brains.
It's interesting how this book jumps right into what it calls quantum mysticism.
Oh, quantum mysticism. I like that.
Yeah, have you ever heard of it? Like the idea that quantum mechanics somehow proves we've got souls or can heal ourselves just by thinking?
Yeah, I've definitely come across that kind of stuff.
It even mentions Deepak Chopra in his book Quantum Healing, where he claims some pretty wild things.
Like what?
Oh, curing cancer with the power of the mind, reversing aging, even achieving immortality, all through quantum principles.
Okay, so that's a lot to unpack right there. I mean, if it were that easy, wouldn't we all be living forever by now?
Right, exactly. But the book doesn't just dismiss these ideas as, completely out there. It actually explores why they're so popular and why people find them so appealing.
I can see that it's definitely a seductive idea, this notion that we have this untapped potential within us, thanks to the mysteries of quantum mechanics.
Absolutely. And what's even more intriguing is that the book brings up Sir John Eccles, a Nobel Prize-winning neuroscientist.
Okay, a real scientist.
Yeah, a heavy hitter. He actually proposed that consciousness itself comes from quantum tunneling happening in the brain.
Whoa, that's a bold claim.
It is, and it's been met with a good deal of skepticism from the scientific community.
Makes sense. I mean, it sounds pretty far out there, but I'm curious about the evidence. Is there any actual scientific backing for these claims?
That's the million-dollar question, isn't it? And the book does a really good job of highlighting the lack of solid scientific evidence for a lot of these quantum mysticism ideas.
So it's not that they're necessarily wrong, it's just that they haven't been proven right.
Exactly. And many of them come from sources outside of mainstream neuroscience, so they haven't really been tested in a way that would satisfy the scientific community.
So are we saying then that these ideas are just too out there for science to even bother with? Or is it more that we just haven't developed the tools or the methods to properly investigate them yet?
I'd say it's more the latter. We're still in the early stages of understanding both quantum mechanics and consciousness.
Yeah.
So it's too early to say for sure whether there's any real connection there.
Fair enough. So we've got quantum healing consciousness, all supposedly explained by quantum mechanics, but the evidence is still lacking. Okay, so where do we go from here?
Well, the book takes us to a fundamental question that's at the heart of this whole debate. Can these quantum effects that we observe at the subatomic level actually have an impact on something as large and complex as the human brain?
Ah, the bubbling up problem, right? How can these tiny quantum events possibly affect our thoughts and actions?
Precisely. And to illustrate this, the book uses a really interesting example, photosynthesis in plants.
Okay, so how does that relate to free will?
Well, it turns out that quantum effects are actually at play in photosynthesis. The process where plants use sunlight to create energy.
So we're saying there's quantum stuff happening in plants.
Exactly. It's a real-world example of how these quantum phenomena can influence biologic processes.
Okay, I'm starting to see the connection here. So if quantum mechanics can affect plants, could it also affect our brains and therefore our choices?
That's the idea. But then the book throws a curveball by introducing this concept called decoherence.
Decoherence? What's that all about?
It's basically the idea that in large, noisy systems like the brain with trillions of particles constantly interacting, those delicate quantum effects tend to get washed out.
So it's like trying to have a quiet conversation in a crowded room.
Exactly. There's just too much going on for those subtle quantum signals to really make a difference.
Okay, so the brain is this bustling marketplace of neural activity, and those quantum whispers are getting drowned out. But does that mean quantum mechanics can't influence the brain at all?
Well, not so fast. The book presents both sides of the argument. Some researchers believe that quantum effects might still play a role despite the challenges of decoherence.
Okay, let's hear it. Who are these brave souls taking on the decoherence problem?
For instance, there's Peter C., who focuses on these things called glutamate receptors in the brain.
Glutamate receptors, those are like the communication hubs between brain cells, right?
Right, and the C suggests that magnesium atoms, these tiny particles, can block these receptors, and that this blocking might be influenced by quantum effects.
So it's like those magnesium atoms are little gatekeepers deciding which signals get through based on some kind of quantum whimsy.
That's a fun way to think about it. The book also discusses Jeffrey Schwartz, who thinks that ion channels are another crucial part of brain cell communication, could be subject to quantum influences.
Okay, so we've got gatekeepers and ion channels, all potentially influenced by quantum mechanics. It's getting pretty complex.
And then there's the really controversial theory put forth by Stuart Hameroff and Roger Penrose.
Oh, yeah, I've heard of them. They're the microtubule guys, right?
Exactly. They believe that consciousness itself arises from quantum processes occurring within these tiny structures called microtubules, which are found inside brain cells.
Okay, so that's a pretty radical idea, consciousness emerging from microtubules through quantum mechanics.
It is, and it's been met with a lot of pushback from the scientific community.
I can imagine. So we've got all these different theories. Some scientists think quantum mechanics could be involved in brain function, but they haven't quite figured out how. And there's a lot of healthy skepticism surrounding these ideas.
Right, and the book brings up physicist Max Tegmark, who's done some calculations showing that quantum states in microtubules would decay way too quickly to have any real impact on brain activity.
So it's like those quantum effects are fleeting sparks that fizzle out before they can ignite anything significant.
Exactly, and even if those sparks exist, the sheer scale of the brain makes it improbable that random quantum events could consistently influence our behavior in a meaningful way.
Okay, so we've got this bubbling up issue where it's hard to see how these tiny quantum events could translate into large-scale effects in the brain. Plus, there's decoherence working against those quantum effects. But hold on. What about all the seemingly random stuff that happens in our brains?
What do you mean?
Like sometimes I just get a random thought or an idea pops into my head out of nowhere, or I do something I wasn't even planning on doing. Could that be quantum mechanics at work?
That's an interesting question. And it leads us to the next part of the book where it delves into the concept of neuronal spontaneity.
Neuronal spontaneity. What's that?
It refers to the seemingly random activity that occurs in our neurons, those brain cells that are constantly sending and receiving signals.
So we're talking about randomness within the brain itself.
Exactly. And the book discusses the work of Bernard Katz, who studied how neurons release neurotransmitters.
Those are the chemical messengers that allow brain cells to communicate, right?
Precisely. And what Katz discovered is that even though the release of these neurotransmitters sometimes appeared random, it was actually being regulated by factors outside the neuron.
So there's more to it than just pure randomness.
Right? Things like hormones, disease states, and even sensory experiences can influence this seemingly random activity.
So it's like flipping a coin. It might seem random, but the force of the flip and the air currents all play a role in determining whether it lands on heads or tails.
That's a great analogy, and this leads to a really intriguing idea that the book calls determined indeterminacy.
Determined indeterminacy. That sounds like a paradox.
It kind of is, but what it means is that those deterministic processes in our brains, the ones with clear causes and effects, can actually influence the likelihood of these seemingly random events happening.
So even randomness in the brain is subject to some degree of order and control.
Exactly, and the book emphasizes that even this spontaneous activity in neurons serves important purposes. Well, for one, it helps to keep synapses, those connections between neurons active, even when we're not actively thinking about something. It's like a background hum of neural activity that keeps things running smoothly.
Interesting. So it's not just random noise. It's actually helping our brains function properly.
Right, and it also plays a crucial role in the developing brain, helping to wire up those neural connections as we learn and grow.
So even though it might look random at first glance, this neuronal spontaneity is actually contributing to the overall order and complexity of the brain.
Exactly. And while it might be tempting to see this randomness as evidence of quantum mechanics directly influencing our behavior, the book cautions against jumping to that conclusion.
Okay, so we've got this determined indeterminacy, where randomness in the brain is influenced by other factors. But what about the argument that quantum mechanics does play a role in free will? How does the book address that?
That's where we get to the heart of the matter. And to explore this, the book presents a thought experiment.
I love thought experiments. They always lead to some mind-bending scenarios.
This one is no exception. Imagine for a moment that quantum indeterminacy did influence our behavior on a large scale. What would that actually look like?
Okay, I'm imagining a world where people are like walking contradictions, making opposite decisions at the same time, like ordering a pizza and a salad, then changing their mind a million times before the waiter even arrives.
That's a vivid image, and the book highlights this problem of randomness. If our actions were truly based on random quantum events, it wouldn't really be free will, would it? It would just be unpredictable, chaotic behavior.
Yeah, that's not how we experience free will. It's about making choices based on our values and beliefs, not some random roll of the dice at the subatomic level.
Precisely, free will, as we understand it, involves intentionality and consistency, not just random actions.
But hold on, some people argue that we can somehow harness or control this quantum randomness to make meaningful choices. How does the book tackle that idea?
That's where things get even more interesting. The book dives into two proposed models for how we might be able to harness randomness, filtering, and messing.
Okay, those sound intriguing. Filtering and messing with us. Let's unpack those, starting with filtering. What's that all about?
Imagine your brain is constantly generating a vast array of possibilities. Some good, some bad, some totally nonsensical. The filtering model suggests that there's a conscious filter shaped by your values and experiences that sifts through all these options and selects the ones that align with who you are and what you want to achieve.
So it's like our brains are a giant brainstorming session, and our conscious minds are the editors choosing the best ideas and tossing out the rest.
Exactly. And the book uses analogies like evolution, where natural selection acts as a filter, weeding out organisms with unfavorable traits, or the immune system, which generates a massive army of antibodies, but only the ones that match a specific threat get selected.
That makes sense. But if our conscious minds are the filters, where do those filters come from in the first place? Are they also just a product of random quantum events?
That's a key challenge for the filtering model. If our values and character are also just the result of random chance, it's hard to see how that would give us genuine free will.
It's a bit of a chicken and egg problem. You need the filter to make choices, but you also need choices to shape the filter.
Okay, what about the messing with model? How does that one work?
This one is a bit more out there. It suggests that our conscious minds can somehow directly influence quantum events happening in our brains to produce the outcomes we desire.
Wait, so our minds are like puppet masters pulling the strings of quantum mechanics to get what we want? How is that even possible?
That's the million-dollar question. The book explores some ideas from philosophers like Robert Cain and Peter C., who propose that maybe the brain has evolved this incredible ability to amplify or exploit quantum randomness to make things happen.
But wouldn't that require some sort of feedback loop between the conscious mind and these quantum events? How could the mind even know which quantum events to influence and how to influence them?
You've hit on one of the major challenges with the messing with model. We lack a clear understanding of how this kind of mind-matter interaction could actually work in a biological system. It sounds like this model is running into the same problem as the filtering model. Even if we could influence these quantum events, we still need to explain where that intention to do so comes from.
Exactly. And the book also points out the inherent contradiction in this idea of controlled randomness. How can something be both random and controlled at the same time?
It does seem logically paradoxical. Okay, so both of these models for harnessing quantum randomness have some serious flaws. Where does that leave us in terms of understanding free will? Is quantum mechanics just the wrong tool for the job?
That's a great question, and it leads us to some even deeper questions about the nature of consciousness and the limits of science, but we'll have to save those for the next part of our deep dive.
You've got me hooked. I can't wait to delve deeper into this mystery. Stay tuned, folks. We'll be right back after a quick break.
Okay, so we've really gone deep into these different models of how quantum mechanics could potentially explain free will, but it seems like we're hitting some roadblocks, some pretty big issues with these ideas. Yeah, you're right. There are definitely some major challenges, but the book doesn't completely throw out quantum mechanics altogether. It just suggests that it's probably not the whole story when it comes to free will.
So it's not a complete rejection, but more like a cautious skepticism.
Exactly. The book acknowledges that there's still a lot we don't know about both quantum mechanics and consciousness, so it keeps the door open for future discoveries. But for now, the evidence just isn't there to support those strong quantum free will claims.
I see. So it's not about saying quantum mechanics is definitely wrong. It's more about saying that we need more evidence before we can draw any firm conclusions.
Right. It's about being scientifically rigorous and not jumping to conclusions based on speculation or wishful thinking.
That makes sense. I guess it's just tempting to think that something as mysterious and mind-boggling as quantum mechanics could explain something equally mysterious, like free will.
I know what you mean. There's a certain allure to those kinds of explanations, but the book makes a really important point about the difference between rejecting simple explanations and embracing magical thinking.
Can you elaborate on that a bit? What's the distinction there?
Sure. The book acknowledges that some people might see the rejection of quantum free will as a victory for reductionism. The idea that everything can be explained by breaking it down into its smallest parts. But the book actually celebrates the incredible complexity that emerges from the interaction of countless components in systems like the brain.
It's like that saying, the whole is greater than the sum of its parts. You can't understand the behavior of a flock of birds just by studying individual birds in isolation. There's something about how they interact that creates these beautiful emergent patterns.
Exactly. And the book argues that just because we can't fully explain consciousness or free will in terms of neurons and synapses doesn't mean we should give up and say, well, it must be magic then.
So it's about acknowledging the limits of our current understanding while still being open to new discoveries and new ways of thinking about these complex phenomena.
Precisely. The book encourages us to embrace the mystery, to keep asking questions, and to be open to findings that might challenge our current assumptions.
I like that it's about approaching these big questions with the sense of humility and wonder, okay, so we've explored the allure of quantum mysticism, the bubbling up problem, neuronal spontaneity, and the challenges of harnessing randomness. It seems like the book makes a pretty strong case against quantum mechanics being the key to free will. But where do we go from here if quantum mechanics isn't the answer? What is?
That's the million-dollar question, isn't it? And unfortunately, the book doesn't offer a neat and tidy solution. It acknowledges that the quest to understand free will has been a philosophical and scientific puzzle for centuries.
So are we just left with this unsolvable mystery, or does the book at least give us some clues about where to look for answers?
It definitely doesn't endorse any specific alternative theory. It's more about encouraging us to think critically about the assumptions we make about free will and to be open to different perspectives.
So it's about asking the right questions rather than providing definitive answers.
Exactly. The book leaves us with this thought-provoking challenge. If quantum mechanics doesn't explain free will, what it does, and it encourages us to explore a wide range of ideas from neuroscience and psychology to philosophy and even computer science.
It sounds like we need to take a multidisciplinary approach to this problem, bringing together insights from various fields of study to really get a handle on this slippery concept of free will.
Absolutely. And the book emphasizes the importance of considering both the biological and the experiential aspects of free will.
Can you break that down a bit? What do you mean by the experiential aspects of free will?
Sure. Think about how it feels to make a choice.
Mm.
You have this sense of agency, this feeling that you're the one in control, deliberating over different options, and then willing yourself to act. The book argues that we can't ignore this subjective experience of free will, even if it's hard to explain in purely scientific terms.
So it's not just about understanding the mechanics of the brain. It's also about understanding how those physical processes give rise to our conscious experience of making choices.
Exactly. And the book suggests that perhaps the answer to the free will question lies in this complex interplay between our brains, our bodies, and the world around us.
Okay, so we're looking at a complex system with multiple levels of interaction, a whole network of influences that shape our choices. That sounds like a pretty daunting challenge to unravel.
It definitely is. But the book reminds us that science is an ongoing process of discovery, and we shouldn't be afraid to embrace the unknown, to keep pushing the boundaries of our understanding.
I like that it's kind of exciting, right? The fact that we don't have all the answers yet means there's still so much to explore and discover, but this whole conversation's brought up another question for me. If free will isn't just about random quantum events, does that mean our choices are predetermined? Like, is everything we do already set in stone?
The age-old debate between determinism and free will, it's a question that has occupied philosophers for centuries, and the book doesn't shy away from this debate.
So it's not taking sides in this philosophical battle.
Right, it presents both sides of the argument and encourages us to grapple with the implications of each perspective, to form our own conclusions based on the evidence and our own reasoning.
Okay, so we're left to ponder this deep philosophical question, but I have to ask, if our choices aren't truly free, what does that mean for our sense of morality and responsibility? Like, if we're just puppets on a string, can we really be held accountable for our actions?
That's a huge question, with profound implications for our legal systems, our ethical frameworks, and even our personal sense of self. And the book doesn't offer any easy answers.
So it's acknowledging the weight of these questions without pretending to have all the solutions.
Exactly. It's more about prompting us to think critically about these issues, to consider the different perspectives, and to engage in thoughtful dialogue about the implications of different views on free will.
Yeah. I appreciate that it's about fostering intellectual curiosity and encouraging us to wrestle with these complex questions, even if there are no easy answers. Okay, so we've explored quantum mysticism, debunked some popular theories about quantum free will, and delved into some pretty deep philosophical territory. Where do we go from here? What's the main takeaway from all of this?
I think the most important message is that the quest to understand free will is far from over it. It's an ongoing journey that requires humility, curiosity, and a willingness to challenge our own assumptions.
And even if we never arrive at a definitive answer, the very process of exploring these questions can deepen our understanding of ourselves and the universe we inhabit.
Absolutely. It's about embracing the mystery and appreciating the complexity of the human experience.
Well said. So if you're fascinated by these big questions about consciousness, free will, and the nature of reality, keep exploring, keep asking those tough questions, and keep those minds open. We'll be back soon with more deep dives into the mysteries of the human mind and the world around us. So we've pretty much ruled out quantum mechanics as the answer to the free will puzzle. But this whole conversation has got me thinking about something. We often hear this phrase, the ghost in the machine, when talking about consciousness, is that where the answer lies, is there something more to us than just our physical brains?
Ah, the mind-body problem. A classic and a tough one to crack. You're right. It raises a whole bunch of questions, but the book doesn't really go down the path of dualism.
Yeah.
That idea that the mind and body are completely separate things.
Okay, so no ghost in the machine then. But if it's all just neurons firing, how do we explain that feeling of making a choice, that sense of agency we all experience?
Yeah, that's the tricky part. The book seems to lean towards this idea of emergent properties. Remember that flock of birds analogy we talked about earlier?
Yeah, where the flock's behavior is more than just the sum of the individual birds.
Right, so maybe consciousness, including our sense of free will, emerges from this incredibly complex interplay of billions of neurons, all those connections, and the constant feedback loops between our brains, our bodies, and the environment. It's not about a separate mind controlling things. It's about the whole system working together to create the conditions for conscious decision-making.
Okay, I can see that, but it's still mind-boggling to think that all these physical processes somehow give rise to our subjective experience of making a choice.
It is, and that's what makes consciousness such a fascinating and challenging area of study. The book really highlights how much we still don't know about how the brain works, especially when it comes to things like consciousness and free will.
So it's more about acknowledging the vastness of the unknown than claiming to have all the answers.
Exactly. And who knows, maybe one day we'll have a much clearer understanding of how consciousness emerges from the physical matter of the brain. But for now, it remains one of the biggest mysteries in science.
Well, until then, it seems like the debate about free will and determinism will continue to rage on. But here's something I've been wondering about. If we don't have a definitive answer to the free will question, is there any practical advice we can take away from all this? I mean, we make decisions every day, and it's hard not to think about whether we're really in control or not.
That's a really important point, and the book does offer some guidance. Even though it doesn't give us a step-by-step guide to free will, it encourages us to focus on what we can control, our actions, and their consequences.
So instead of getting lost in the philosophical weeds, we should focus on making choices that align with our values and taking responsibility for the outcomes.
Exactly. It's about recognizing that even if we don't have complete control over every thought or impulse, we still have a choice in how we respond to them, how we act, and what kind of impact we want to have on the world.
That's actually a really empowering message. It's about taking ownership of our choices and recognizing that we have the power to shape our own lives and influence the world around us.
Absolutely. And the book suggests that this focus on our actions and their consequences can lead to a greater sense of agency and purpose, regardless of whether free will is ultimately an illusion or not.
So it's not about getting bogged down in the philosophical debate. It's about living a meaningful life by making conscious choices and striving to make a positive difference.
Well said. I think that's a great takeaway from our exploration of free will and quantum mechanics.
It's been a wild ride exploring these mind-bending concepts from quantum mysticism to the complexities of the brain and the philosophical depths of free will and determinism.
It has, and I hope our listeners have enjoyed this deep dive into the mysteries of consciousness and the human capacity for choice.
I think the biggest takeaway here is that the quest to understand free will is an ongoing journey. It's about staying curious, asking tough questions, and being open to new ways of thinking about ourselves and the universe we inhabit.
And even if we never find a definitive answer, the process of exploring these questions can enrich our lives and help us make more conscious and meaningful choices.
So keep those minds open, folks, and keep exploring the fascinating world of science, philosophy, and the human experience. This is